Hello, Math Studies students. I have a video here on topic 1. We're going to look at scientific notation or standard form. You can see in the syllabus here that it's 1.3. They have a funny way of writing all this information, but basically the A here has to be between 1 and 10. Less than 10 has to be one digit, and then k is an integer for the power of 10. So basically it's some number times a power of 10, which moves as our decimal place. Okay, so we're going to be looking at a sphere here, paper 1 question, and we're going to calculate the volume of a sphere. Actually, we're going to assume the planet Earth is a perfect sphere with a radius of 6,371 kilometers. Okay, so I need a formula for the volume of a sphere. You can see it down here under topic 5 in the formula booklet, 4/3 pi r cubed. So again, how can we use the calculator to make this simple calculation? So again, we're looking at A here. 4/3 pi r cubed, and r was 6,371 cubed. So that's going to be our calculator input for this question. I can use the fraction trick one more time for my 4/3, or I could have just done 4 divided by 3. It doesn't, going to be the same thing. All right, and then pi r cubed. You can see the pi is under the caret here, blue, and then 6,371. I'm going to put 6,371 in brackets before I cube it, just to keep good habits. And then how do I cube it? I can use this key for the exponent key, okay, and cube it. You can also use the math key, same idea. Okay, and then we get our response, and you see this is actually a scientific notation right here. We have a very long decimal number times 10 to the power of 12. So in essence, you're moving the decimal point to the right 12 places. So that's like a trillion's cubic kilometers. Okay, so we didn't want to write out that huge number. We're going to use a power of 10 instead to write it. Okay, so 1.0832, etc. Okay, make sure I round it correctly. That's a 0, so I think I'm okay at that point. And again, the units are important here, kilometers cubed, or I'll lose a point overall on the paper for units if I forget my units somewhere along the line. Okay, and then we're given actually the volume of the moon here in scientific notation also. And that's 2.1958 times 10 to the 10th kilometers cubed. And I just want to find the ratio here to figure out how many times greater the volume of Earth is than the volume of the moon. So my calculation is basically just going to be, again, the big number divided by an almost as big number. Okay, so again, I'm going to have the Earth volume divided by the moon volume. Okay, that's going to be my workings. Take a look at the calculator here again. I'm going to use the fraction trick one more time. And I'm going to use another trick to grab that Earth volume. I just arrow up, hit enter, and I grabbed it, and it went into my fraction. Okay, and then I want to put in the scientific notation number in the denominator standard form. Again, 2.18, 2.1958. Now I have the option. I can do times 10 to a power, or I can use the exponent key here, enter exponent key here, or I can use a math key or some other way, but I'm going to use the enter exponent key here, blue, and then the exponent is 10, okay, times 10 billion, okay, and then I get my ratio of how many moons can I fit inside the Earth, basically, in terms of volume, and I get 49.33. The question states round to the nearest integer, okay, so my answer is going to be 49.